Welcome to Lessons in Logic number 46, the Energizer Bunny series. It just keeps going and going. This is, I think, an egrets at sunset at Sanyati Baptist Mission, rural Zimbabwe. Probably a photo taken by my father in the 90s. I don't know what's up with the lighting. I probably tried to take a photo of this photo. Or I took a photo of a hard copy photo with a phone, but who knows? Maybe the original had bad lighting too. I still think it's pretty enough. I don't know where the jacaranda leaves with the moon in the background picture is, but I should find that sometime if I can. All right. Short overview of proposition logic, and then practice with one nifty argument, which I think we got from Boethius. In proposition logic or statement logic, without reviewing every dang thing because I'm too tired and I don't want this video to be too long. In proposition logic or statement logic, we study the structure of an argument, the form or the pattern of an argument, the pattern of reasoning, to see whether the pattern is such that it's not possible for the premises to be true and the conclusion true at the same time, conclusion false at the same time. If it's not possible, then the argument is valid. And we do this studying of the structure, the pattern of the argument, by symbolizing the argument. We use capital letters to symbolize the smallest statements in an argument, meaning the statements that are not made of any other statements. Now, they might be long statements, actually. Mark is a fervent supporter in anti-disestablishmentarianism. It has a whole lot of syllables, but it's an atomic statement. Mark doesn't like coffee is not an atomic statement, even though it has fewer syllables. So smaller does not mean smallest in length. I hope no one was ever confused by that. Smallest means not made of any other statements. An atomic statement or a simple statement or an atomic or a simple proposition is a statement not made of any other statements. And even a short statement in terms of how long it is, like Mark does not like coffee, if it's a negation of another statement, is made of that other statement. It's made of the statement, Mark likes coffee. Anyway, we use capital letters to symbolize the atomic statements, and we have sophisticated methods of symbolizing the rest of the argument, and then we do cool stuff. What are the cool things we do? Well, first, we have the famous forms method. It works on any argument in proposition logic or statement logic that uses famous forms. It can prove the validity of such an argument, or if it's one of those invalid forms, it can prove invalidity, as long as you correctly represented the specific form of the argument. No time to review that in detail. Go back to the relevant videos. Short overview here of what we've done. Short review, that's all. The full truth table method works on any argument there is, assuming you can symbolize that argument in propositional logic symbolism stuff. I hate the way I phrase that. Using our symbolization strategies in proposition logic, you can test any argument for validity using the full truth table method, unless you run out of time. If there's a lot of atomic statements, you will run out of time. 20 atomic statements is 2 to the power of 20 rows in your full truth table. And I'm thinking that's a lot of rows in the truth table. You could spend a long time filling in all those little boxes. It almost sounds tempting, but it would be foolish for me to try. So the abbreviated truth table method makes it simpler. It can again be used on all arguments that can be symbolized using our symbolization strategies in proposition logic, but with no exponential difficulties with the number of atomic propositions. 20 atomic propositions, depending on what the argument is, might be finished with 1 or with 2 or with 3, or maybe a few more rows of an abbreviated truth table. It depends on the argument, but sometimes really just 1. Now this again, like all our methods so far, will prove validity or invalidity. Now, the counterexample method is actually something we can use with proposition logic. It can prove the invalidity of an argument form, and it proves the invalidity of an argument if we've identified its specific form, and it only works on invalid arguments. But we need to add a row to this. We didn't do counterexample. I don't think we did the counterexample method with our unit on proposition logic. We did it in our intro unit, but to be thorough, it seemed appropriate to mention that we can do it. It is a thing in proposition logic that we've studied in this series. And now proofing method. This is not in our chart, and I need to add it to our chart. It works on valid arguments only. Now I have to decide, do I want to talk about what you can do What else you might be able to do? How you could modify the proofing method to prove invalidity? No, I don't want to talk about it, so I'll just preview it. A reductio ad absurdum proof is like an abbreviated truth table. In fact, it uses precisely the same logic as an abbreviated truth table. Take the premises to be true, assume the conclusion is false, show that a contradiction follows from it if the argument's valid, and if not, just show a set of truth conditions for every proposition in the argument, and if there's no contradiction, then the argument's invalid. Why on earth can't you do that with the reductio proof? You just end up never closing up the proof. You need to announce, you need a new proofing rule that allows you to announce within the scope of the assumption that the conclusion is false. We've been able to derive or restate a truth value for every single proposition in the argument, atomic or otherwise, and there's no contradiction within the scope of this subproof. Therefore, the argument is not valid because the assumption of a false conclusion with true premises does not lead to a contradiction. In other words, if the abbreviated truth table method works to prove invalidity, since it's the same thing as a reductio proof, you should be able to use a modified reductio proof to prove an argument to be invalid. But let's not put that in this video, or indeed in this series, because I'm too exhausted. It's not a method of, it's a proofing technique that requires a new proofing rule that I think has never been used. I'm not going to introduce it right now. Maybe some other time. All right. Translation and truth tables. This appears to be a last effort, a last piece of practice in statement logic. Let's symbolize this argument and test it for validity. I think we're going to use a truth table. Although, I don't know, I might want to just prove the argument. I don't think I want to do both because, again, I'm exhausted. The argument, I think, comes from Boethius, Consolation of Philosophy, Book 3. If either money does not last or is never enough for the person who loves it, then money is not to be sought as an end in itself. If power does not last, then power should not be sought as an end in itself. If fame is based on the fickle prejudices of your culture, then fame should not be sought as an end in itself. Money does not last. Money is never enough for the person who loves it. Moreover, power does not last, and fame is indeed based on the fickle prejudices of your culture. There is only one conclusion: neither money nor power nor fame ought to be sought as an end in itself. Now, I've color-coded our symbolization here. I've color-coded the beginnings of our symbolization, the first step to the symbolization process, if you divide it up into little steps. This is one step. Do the right sort of underlining, color-coding, or whatever. Maybe draw some arrows or something, if that works for you. The next step would be to write out things like, if either not L or not N, then not M, which is what our first premise appears to be. I'm going to simplify a bit and go directly to the symbolization using our symbols. Let's see. We're using L to symbolize the atomic proposition money lasts. N to symbolize the atomic proposition money is enough for the person who loves it. Although I don't like this. Let's change it to E. E for money is enough. L for money lasts. E for money is enough. M for money is to be sought as an end in itself. No, I can't do that. Oh, M. Perfect. M for money is to be sought as an end in itself. L for money lasts. E for money is enough for the person who has it. And then fame is to be sought as an end in itself. F. P for power is to be sought as an end in itself. And then S for power lasts. And B for fame is based on the fickle prejudices of your culture. I have failed to come up with a symbolization scheme where the capital letter we're using to symbolize a proposition helps us keep track of what proposition it symbolizes. S doesn't connect anything to power lasts. So I sort of failed there. Anyway, let's use it. This should be fine. I'm going to need an arrow. I don't think I have any in my clipboard. Let me go find an arrow symbol. All right, so our first proposition is if either not L or not L or not E, then not M. But observe my mistake in the highlighting. There we go. Try not to get confused by the negatives here. Also, in the conclusion, the phrase ought to be sought as an end in itself would have to be in green, purple, and gold here for all three atomic propositions it's expressing. In fact, all three atomic propositions it's denying. So this color coding system does have disadvantages. It's easy to make silly mistakes like I just made here. All right, so I'm doing the first proposition. It's an if-then, and the if clause is either money does not last or money is not enough for the person who has it. Tilde L wedge, tilde E, all that. And if all that, then money is not to be sought as an end in itself, tilde M. Next premise, if power doesn't last, then power should not be sought as an end in itself. If not S, then not P. If fame is based on the fickle prejudices of your culture, then fame should not be sought as an end in itself. If B, then not F. Fourth premise, money does not last. Next premise, money is never enough for the person who loves it. And then power does not last. And then fame is based on the fickle prejudices of your culture. So, well, we've got an tilde L, tilde E, tilde S, B, fame is based on the fickle prejudices of your culture. There we go. And then finally, there's only one conclusion. None of these things is to be sought as an end in itself, which is to say, I'm going to need a therefore symbol too, aren't I? Therefore, not M and I'm going to need a dot symbol, aren't I? I'm going to need a dot, a not M and dot not P and not F. Money is not to be sought as an end in itself. Power is not to be sought as an end in itself. Fame is not to be sought as an end in itself. So now I need to find the dot. There we go. Control X, Control V, Control A, Control X for removing any obnoxious formatting. So the conclusion is these things are not to be sought as ends in themselves. Now, you could phrase this with either's and or's if you prefer. You could have phrased it not M or P or F, as long as you get your parentheses right. That would have been totally fine. They're equivalent on De Morgan's. Do get your parentheses right. So I think what we're going to do is a proof. I do not want to do a truth table on this. It seems unpleasant to me. Or maybe I should do a truth table. How many rows? I think I would only need one row. How many? Yeah, I should be able to do this with one row. So maybe I will do a truth table. How many boxes would I need? Atomic propositions I've got 1, 2, 3, 4, 5, 6, 7. Premises. No, I am absolutely not doing an abbreviated truth table. Let's go straight to a proof of this. Let's keep it simple. No complex. No complex reductio proofs. not even a working backwards strategy. This is a simple case where working forward strategy will work just fine. B and B arrow tilde F will give us tilde F by modus ponens. And probably we will not need to come back to those premises again. And we can do another modus ponens where we find it. Tilde S and P. Tilde S gives us tilde P by doing a modus ponens on tilde S arrow tilde P line 2. So lines 2 and 6 modus ponens tilde S arrow tilde P. If not S, then not P. Not S, therefore not P. Now, do we have one more simple modus ponens? Not yet. We're going to have to somehow convert not lines 4 and 5 here into the antecedent to line 1. How do we do that? Well, first we combine them, and then I think we're going to do a simple De Morgan's. We combine them by tilde E and tilde L. What rule is that? I believe the rule is conjunction. That's conjunction on lines 4 and 5. Don't make it 5. Conjunction on lines 5 and 4. Don't make it 4 and 5 in the wrong order. Then you'd have tilde L dot tilde E, and you need them in a different order. Sorry. Maybe you should do it 4 and 5. We want the L to come first. So we actually do want 4 and 5. Sorry, my mistake. Illustrating the mistake I'm telling you not to make. Tilde L dot tilde E by conjunction on lines 4 and 5, and we probably won't need lines 4 and 5 again. So now I think we're going to De Morgan's these. Tilde L dot tilde E means not one and not the other. Oh, you know what? Very simple. We don't need any kind of fancy De Morgan's. In fact, we didn't need to use both premises. Let's do this in an easier way. Tilde L and tilde E, we only need one of them. Using line 4, with a simple addition rule, we can totally get what we need. Tilde E or tilde E. In fact, yeah, I should have remembered this. Those two premises are sort of redundant. They're part of a stronger rhetorical case in case someone doubts that money doesn't last or has trouble understanding the proposition that money is never enough for the person who loves it or something. But if either of them is the case, then that's sufficient to establish that money is not an end in itself, according to the argumentative strategy and Boethius' approach here. It's actually a very simplified version of what Boethius will say in Book 3, but it is very much like Book 3. So now, using modus ponens on 10 and 1, we get a simple tilde M. And now I think we have everything we need to get to the conclusion. We just need to do the conjunction rule. But we have to do it twice. We're not supposed to skip steps, remember. I think we want to first do this one. Tilde P dot tilde F by conjunction on lines 9 and 8. Now here's where you don't want to get them out of order. If you do 8 and then, if you do 8 and then 9, then you're going to have tilde F dot tilde P, and you need the tilde P to come first so we can match the conclusion. You could do it the other way, but then you have to do an extra commutation step. So now I think we are this close to our final conclusion. We just need one quick step. We can even copy and paste the conclusion and make sure we cite the rule properly. The rule is going to be a conjunction on lines 11 and 12, and we're done. It's a valid argument. Good job, Boethius. All right. Thanks for watching, and I think we are finally finished with statement logic. And next time, we are doing inductive logic. See you then.